My name is Etienne, and I'm the founder of CEO of Vention. Vention is a digital manufacturing platform for custom factory equipment or machine design. Some of our clients refer to us as cloud-hosted Lego. So I'll talk more about that today. Just as by raising a hand, how many of you have walked in a manufacturing floor before? Whether it's car or airplane or consumer electronics, so roughly a third of the audience or so. So on every manufacturing floor, there's two types of manufacturing asset. There's everything that is off the shelf, the CNC, the wave soldering machine, the robots, the press. And there's everything that is custom made. Assembly jig, inspection jigs, test benches, robot bases, fencing, and so on. And there's a reason why there's so many custom assets is they are custom to the product being manufactured. So for every device that we know, every product that we know, this table, this TVs, this camera, there's even more products that are designed of custom for the sole purpose of either manufacturing or testing those goods. So that's the space we're in. The process being used to design, manufacture, and commission those pieces of equipment basically hasn't changed for 25 years. And I know that for a fact because that's how I started my career at 19 years old, sitting behind one of the CATIA workstation designing those equipment. Actually, I designed a lot of projects in the aerospace world. I was designing fixtures for the landing gear of the 787 and the A380 landing gear. And the process I was basically using to design those projects hasn't changed for a very long time, and it's not a matter of cloud-based CAD or desktop install CAD. It has nothing to do with that. It has to do with the number of interfaces a machine designer has to go through to, again, find the vendor parts he needs, design his custom piece of equipment, find a supplier that's going to manufacture it, and then commission that piece. So I'll talk to you about that journey that I've navigated several times. So when I had to design a fixtures for a landing gear, the journey was always the same. I was going to 10 to 15 different industrial distributor websites to find parts, motors, sensors, gears, bearings. And I would pray for the 3D model of all those parts to be somewhere online. Most of the time they were there, and sometimes they were not. So you recreate that geometry, and you bring all of those parts into your desktop install CAD, whether it's SolidWorks, CATIA, or Inventors. Then you realize, okay, I have all those vendor parts. Everybody have used standard, but everybody used different one. So as the engineers, you're the one tasked of designing all those custom parts. Those custom frame, custom mounting plate, custom bracket, so you can connect all the vendor parts to one another and create a fully functioning machine. So now you have this virtual prototypes. You're probably 3 weeks in your engineering project, and you want to know how much it's going to cost. So you call procurement, and they're going to tell you, well, I need 2D drawings to get the part quoted. I also need an Excel bill of materials, so prepare all that, and I will send 3 little packages to different shops around my plan to get quotes. So we're waiting a week or two to get a quote from a tooling shop or an engineering firm. You get the quote back, you pick one guy, they start to manufacture the thing, and typically 4 weeks to 6 months later, you finally have your machine that you can commission on your floor. So as you know, it takes a lot of time. Actually, if you look at the amount of interface time or waiting time or wasted engineering hour in the United States, around 5 billion right now. So how can you make that fast? And that was the question that always fascinated me back in the early 2000s designing those machines. How can you make that process literally as fast as almost 3 days or matters of minutes? And that's really the purpose of Vention. But we see a lot of, since Vention was launched a couple months ago, we saw a lot of traction, and we were wondering why is that? What has changed, or why people are actually buying into that, that vision of very short product design lifecycle or machine design lifecycle? So what has changed? There's one thing that is above all, probably most important, Kreenar echoed to it as well, but product lifecycle is getting shorter. If you remind back in the early 2000s, a car platform's life was 6 years. Today it's around 3.5 years. In consumer electronics in the early 2000s, an LED lighting lamp, for example, platform could be around 4 years. Nowadays, around 18 months. So if the product life cycle is getting shorter, the time you have to design, commission, and depreciate the manufacturing asset is also getting shorter. So for me, manufacturing just entered the good enough era, because the manufacturing floor are not designed to last for 40 years or 20 years as they used to be. They're designed to last 5 years, and then they're repurposed, and then you produce something else. So product life cycle is getting shorter. The other thing that is changing in the marketplace right now is people expect to self-commission. You can buy a cobot today, and if you've never touched a robot, you can actually deploy a cobot yourself in your factory, even if you've never touched a robot before. The robot company are designing the robot in a way that is almost self-serve. So this is true for the vision system. For those that installed vision system on an assembly line before, 15 years ago, you were buying the camera, you had to do your own wire to connect the vision system to a computer. Today you get a USB power cord, plug that in your computer, you use template software, and your vision system is running in the same day you installed it. So we see the same trend as well in tooling or in machine design, this space we're in. So I'm a data geek. I love data. And we were wondering, why is that now that we have a platform, now that people are coming to Vention to design custom equipment, why is that some people are so fast and some people take way more time? And what's funny about Vention, for those that know the platform, is we work with modular part. We work with Lego part. Whether it's structural part, motion parts, or control parts, it's Legoed. And everybody designs the same software. So that creates a very level playing field for us to analyze behavior. So we try to look, why are some users so fast? Is it about the experience of the designer? Is it about the number of design they already done on Vention, therefore they know our software better? Or is it about something else? And the only correlation we found was one of product lifecycle. So if you're in a short industry lifecycle versus if you're in a long industry lifecycle, the likelihood of you designing, buying, and commissioning the piece of equipment fast is significantly greater. So why is that, right? Why are people in short product lifecycle industry are just faster? Are they just better than the one in the long lifecycle industries? And there's an economic reason for that. So I'm going to use an example. If I manufacture a cell phone, the life of that device is around 18 months. If I can save 2 months to get my manufacturing floor set up, it's basically 9% of the end product's business case right there. If I manufacture an aircraft, the shelf life of an aircraft is around 30 years. So if I basically save 2 months, it has nothing to do with the business case of the end product. It has no impact. And implicitly, we've noticed that organizations have embedded those behavior. People in short product lifecycle industries just navigate that process much faster. So how do you make product or machine design really, really fast? And the thought you have on this page, those 4 principles, were really the principle that led us to start Vention. The first thing you need is you need to digitalize the process. That means that you need to select the vendor parts, design, order, and assemble in a single environment. No longer engineers can navigate around 15 web, software, and human interface to get their project throughout. It has to happen at one place. The second thing is you have to modularize the hardware, because if you keep working with custom-made parts, it just takes too much time. Keep in mind that any machine in blue you see on this slide has hundreds of parts, right? So just manufacturing the custom part you have there can take weeks and weeks of lead time. So you have to work out a modular part. When you start to inject modular part into a design software, and I'm moving to principle 3, you can do magic, because a 3D cylinder is not a cylinder anymore, it's a wheel, right? And a cube is not a cube anymore, it's a PLC. So when you know what the hardware it is inside the CAD, you can do magic. I know that a wheel can support a load. I know the wheel has a certain rubber geometry on the wheel. I know the PLC can absorb some code. It has a price. It has some input-output. I know all of that because I work with predefined hardware. So you can develop smart algorithm. And smart algorithm basically speed up the design cycle. Not only you have a CAD software that not only understands how the parts can connect, but can help the user predict how the part can connect. So that translates into time saving. So designing a custom palletizer could be a 3 weeks worth of engineering time. Instead of taking 3 weeks, could literally take 2 hours of time because the software helps you out through the process. So if you have those first 3 items, you couple that with world-class warehouse facilities, maybe that use Tive, you can deliver next day. Right? So what does that translate into in terms of process? That means I can design my stuff today out of modular part. As I'm going to design, I'm going to see costs in real time because all of those parts are priced. I'm going to see the assembly time of those components of the entire machine in real time because all of those parts have assembly time. I'm going to be able to see automatic bill of materials, automatic fastener management, and at any point in time I can click order and get my stuff delivered next day. So you basically take a 4 weeks to 6 month custom engineering project and you literally transform that into a couple of days e-commerce experiences. Now, since it's cloud-based, you can collaborate, but more importantly, you can reuse. That means company can share within their company or publicly and can be reused across. Something that has never really been done for the world of custom industrial equipment. So this is how Vention looks. We have blue parts. For those that have seen some of the hardware, it's blue for a reason. We make it compliant with photometry of 3D scanner. Because a lot of our clients use Vention to do inspection jig. And when you use a 3D scanner to scan a part, a lot of the 3D scanner technology use a blue light. So if you use blue part, it makes the jig transparent to the scanner. So we injected in there almost 400 Lego parts, industrial grade Lego parts. Structural, motion, and control. So you can do fixed equipment, you can do automated equipment. And all that hardware exists in a digital form with additional properties that can enable automation in the cloud-based software. And there's also libraries, again, for people to reuse. So what have we learned? The first thing we've learned is there's way more people that need industrial equipment than people that know how to design them. But if you give them a software that do portion of the work for them, you can empower a new class of users to be successful at those. They can be photographers that are doing motion capture with robot. They can be FX studio in Hollywood that now need a special machine to do a special FX for movies. But obviously, the majority of them could also be traditional manufacturing engineers that are in the short product lifecycle industries. The second thing we've learned is it's fast. It's a fraction of the time that you would need using the traditional workflow. All the design time, we make fun of making them in minutes because they're truly minutes. For an engineer that have learned Vention and reuse it again for a second time, most of the design you see here, whether it's an automated piece of equipment, an inspection jig, or some test bench for academia, will be done in less than an hour or so. And the assembly time is also very short. So this is basically how you can take something that traditionally has been done in months, and you can make it in days. So how does that translate into costs? Because time is always cost. So what we did is we looked at project done with a traditional workflow. Those were aerospace project. And we basically compute every single time, every single hour spent by the engineers, by the procurement person to navigate that workflow and how much every piece of hardware, whether it was manufactured, how the vendor parts or custom manufacture costs. And we redid the same damn project in a digital workflow. So on average, you get around 40% saving, but where does the saving come from? Because the hardware is not cheaper, the hardware is pricey, but you compress that engineering time a lot. You basically need a fraction of engineers to accomplish the same thing and a fraction of procurement people to do the same thing when you start to digitalize that process. That's what we've learned. So Vention right now is late seed companies. We have the privilege to work with a lot of the large companies in the United States, and we basically empower our users to do machine design extremely fast for the manufacturing floor. Thank you.
Great, thanks, Etienne. What's the sharpest tip of the spear? How do you go to market? Which part of the industrial world is the most open to something like this?
So as I was saying a little bit earlier, we obviously see adoption more in fast life cycle industries because people value time a lot, right? And really what Vention brings is ease of use and it's time, and industries where people value time, we see very rapid adoption. Now, interestingly, in the world of custom factory equipment, often the designer is the decision maker, right? It's the guys that design the machine that basically define what the specs become to some extent. And those are guys we like to work with.
Great. All right. One question over there.
Oh, it worked. Okay. So do you have hardware vendors on the platform, or do you build hardware for all kind of machinery? And by doing what you're doing right now, are you making the opportunity for like small hardware vendors to come onto your platform and sell their hardware?
So I'll start with the second question. The question was, do we open up the platform so other hardware manufacturers can participate? Currently, we work with partnerships, so it's semi-open, I would say. So we do have a partnership with known manufacturers such as Blakely Wheel or Thompson Industries that we onboard. But as people do in software, a software developer controls its software architectures. We're actually pretty rigid about controlling the hardware architectures because we care about the consumer experiences. So an engineer that will assemble a Vention machine will need a single tool, right? And as I've said at the beginning, all the vendor parts out there that you can buy off the shelf use standard, but they all use different one, which basically force the engineers to do a full engineering project. So that's one of the reasons we control that hardware. So the platform is semi-open. We work with partnership.
thing, two things. One, you mentioned like repurposing and sustainability. Do you have, is that a part of your program? And also, with a startup, would they have, would their time schedule, you're talking about sort of full-blown companies that are in midway in their, would a startup have the same time constraint? Could a startup in a, is it more that the culture has changed and that everybody wants it, or is it, I'm just curious, are you marketing to people who have no machines at all right now?
So it's impossible to have a manufacturing floor with no custom assets. There's always the case. Now, related to the startup question.
They don't have a manufacturing floor yet, though. Would you be involved with them or no?
We actually work with a fair amount of startup, and there's a reason why. Because startup economics are twisted. Because you compete against your cash burn, unless you're already profitable. And in a world where you compete against cash burn, time is money, right? If you can save a month, you save a month of cash burn. So we work with a lot of startup for that reason.
And then the sustainability part?
On sustainability, it's interesting because Vention machines are Lego, right? They can be repurposed, right? It means that if you assemble a piece of equipment, you don't need it later on, you can disassemble and use the same hardware to create something else. We have that implicit demand coming from some of our users to repurpose those machines, and Vention enables that.
What's your pricing model?
Some of the parts. It's some of the parts. So basically, more parts is going to be more pricey. Each part has a price. So we're actually very transparent with our users. They totally understand what they pay for from the get-go. Because as you design in Vention, you see cost goes up as you add part to your assembly, right? So the pricing model is some of the part. Which is interesting because in photography, photography is a very twisted market because there's only a handful of manufacturers if you want very high-end photography equipment. So the price versus a photography equipment versus an industrial piece of equipment could be 6 or 7 times more than for an industrial good. So there's some industries that capture more arbitrage of some of the part pricing than others.
Hey there. So it looks like the examples you were showing were focused on like a machine that would create a single part. Have you had clients or people interested in how do I couple several different machine processes? So if I'm building a jet engine, like I need the fins, but I need the plugs, the spark plugs, and I need all this other stuff in this engine. How do I couple each of these different components?
Into a full manufacturing system, right? So this is a very good question. So far, we mostly work on standalone piece of equipment, right? We're not yet to the point where we can do a full manufacturing system with Vention. So we work on discrete equipment. And very often, those equipment are used to connect off-the-shelf asset, right? You have a CNC. You want to bring a robot, you need a machine tending device, part dispensers, and so on around that CNCs. So they're standalone asset that, when combined, then create a production cell, for example.
Sorry, this question might be a little. How do you design your the blueprint of these machines? Do you get licenses from different manufacturers and then just combine them together, or you have everything created in-house?
So we don't design machine ourselves. We give tools to engineers that do so, right? So our users, it's a self-serve model. So our users come on Vention, start a new project, they toggle into this free design tool, which is an industrial grade, engineering grade tools where they can design their own machine. So the varieties of machine that our users create is really based on their specific use cases, which is very influenced by which end product are they manufacturing, what's the current state of their assembly line or manufacturing setup, and the state of their capacity ramp up on that line. Yeah.
One last one over there.
How do you deal with needy customers or ones that keep changing their mind? So, for example, they got a robotic arm that has 20 Newton meters Z-axis support, and then like all of a sudden, we need 200. How do you deal with support on that?
Sorry, I didn't understand the first part of the question. How do you support?
How do you support needy customers or ones that change their mind? So they get the item from you, the robot that does a certain task, and they realize, this is not good enough. How do you take care of that situation?
Yeah, so we're not in the business of replacing the engineer's brain yet. in a sense that engineers that has to design to their own environment, right? So if they have a robot that has a certain torque specification at the basis, they need to design for that robot. And if they change the robot or they change a task to the robot, it might imply a different piece of equipment, and they would have to redesign. The beauty is they'll be able to maybe reuse some of the parts. Yeah.
Actually, you love people who change their minds, right? It's
I like
buy more
people that
stuff.
change their mind. I like people that change their mind.
All right,
Very good.
thank you very much. It's terrific. Thank you, Etienne.